Okay, let's begin the next example. We have lead concentrations measured in different traditional medicines. We're going to use a 0.01 significance level to test the claim that the average lead concentration is less than 15 micrograms per gram. So null hypothesis, alternate hypothesis. We're doing means here. The null hypothesis here would be that mu is equal to 15, and the alternate hypothesis would be mu, let's see, our default is not equal to, but this says less than 15, so we say less than 15. There is our null and our alternate hypothesis. Now, we don't know anything about the population, so if we figure out which formula we're using, we're conducting a hypothesis test, we're testing a claim, and that claim is a mean with an unknown population standard deviation. Boom, here is our t-test that we're going to use. So the formula is t is equal to x bar minus mu divided by s divided by the square root of n. So I need x bar, mu, s, and n. Okay, mu we know is 15. And n we know because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. Now we need x bar and s. Now I could calculate these using these data points with my calculator, but instead of doing that, I'm going to do it in Excel because it's so much easier. Remember, you can click this tiny button and open your data in Excel, and the data should automatically be there. My data is not there, so I'm going to type it in very quickly. It's 21.5, 8.5. Sorry, typing with gloves on. 20.5. Let me zoom in a little bit so I can see what I'm doing. So 21.5, 8.5, 20.5, 4, 13, 13.5, 6.5, 8. Feel free to skip this part. 6.59. Okay, there's all of my data. Just double checking I typed it correctly. Remember, for Excel, you can do equals average, and then you can average the entire A column. There's my average, and you can do equals standard deviation. Remember, we're doing sample standard deviation of the A column, and we get that. So I'm going to write these two values down. The mean is 11.1, and the standard deviation is 5.957. 255. Okay, so that's the only difference for this problem, is that we had to actually calculate the mean of 11.1 and the standard deviation of 5.957, We had to do those two things ourselves. But now we're ready to go ahead and just plug them into the formula. So let's do that. T will be equal to 11.1 minus 15, which will give us a negative test statistic, but that's okay because it's a left tail, divided by our standard deviation, divided by the square root of n. Grab your calculator. Here we go. We do the entire numerator. And so I'm going to put the entire numerator in parentheses. 11.1 minus 15, put that in parentheses, divided by, and I'll put the entire denominator in parentheses. 5.957,255 divided by the square root of 10. Enter. Oops, my parenthesis is inside of the square root. Negative 2.07, fantastic. That is the result that the book gets. Negative 2.07. So that is our test statistic right there. Before we find the p-value, let's look at the critical value and see what that would be. So the test statistic is t equals negative 2.07. Let's find our critical value. So we have a sample size of 10. That means we have degrees of freedom of 9, and it's a one-tail test at 0.01. So Alpha, it's a one-tailed test, alpha of 0.01, and we have 9 degrees of freedom, which will be 2.821. Notice it's pretty high critical value because our sample size is so small. 2.821 is a pretty high critical value. Okay. So notice I wrote down 2.821, and look, the absolute value of this is going to be smaller than the critical value, so that tells me that we are going to fail to reject. We're going to fail to reject before we even look up the p-value, because the absolute value of this is 2.07. That's smaller than our critical value. We didn't meet the bar. 2.07 is still pretty big. Think of it as kind of like being 2 standard deviations away. So it's still pretty good, but not good enough to reject. Maybe we could have done it at a lower significance level, like 0.05, but not at 0.01. Okay, let's get our p-value. Give me 1 second. Okay. Whoops, I'm on the wrong monitor. Delete that. Delete that. Still a one-tailed test. This time, though, our significance level was 0.01. And our t-score was negative 2.07. That was our test statistic. Degrees of freedom was n-1, which was 9. Okay, go. P-value is 0.034, and that is indeed the correct answer. As expected, we failed to reject. Not significant. P-value is larger than alpha. So I'm going to write down that the p-value was 0.034. And when we come back to our notes, we see that I've written down 0.034 was our p-value. Failed to reject. There is not sufficient evidence to conclude that the mean lead concentration for all such medicines is less than 15 micrograms per gram. So there you go. One more example to go, and then, you know what? I'm actually going to nix that last example. Instead, it's very similar to this one, except I didn't copy down the table. And so if you have any questions about this, please will you let me know? And hopefully, though, it is making sense. The tricky part, believe it or not, is actually figuring out which test to use. And so hopefully I've been showing you how to do that. All right, I'm going to do one more video on this chapter to put a big picture around it, and then we'll be on to chapter 9.